Imagine this for a moment. Somewhere beyond what you call reality, there exists another version of you. Not symbolic, not metaphorical. An actual counterpart, walking their own path in a universe you'll never see. Now imagine both of you moving forward at the same time, unaware of each other, until something rare happens. For a brief instant, the paths of those two universes overlap, not physically, but informationally. And in that overlap, something leaks through. What would you notice? According to theoretical physicist Michio Kaku, if timelines from parallel universes were ever to intersect, the exchange wouldn't happen as objects or people crossing over. It would happen at the level of information. Memory, familiarity, recognition without explanation. You'd suddenly feel like you've been somewhere before. A street that feels known, a place that feels remembered rather than discovered. Buildings, faces, corners of a path that trigger certainty without context. That strange sensation we casually call déjà vu. Almost 8 out of 10 people report experiencing déjà vu at least once in their lives. That statistic alone doesn't prove anything extraordinary. But it does raise an uncomfortable question. What if déjà vu isn't a glitch in memory, but a brush with information that doesn't belong to this version of you? At the moment, this remains a hypothesis. There is no direct proof that déjà vu is caused by overlapping timelines. But something else is worth paying attention to. The idea of the multiverse itself is no longer confined to science fiction or philosophical speculation. For decades, the multiverse existed only on paper. Elegant equations, thought experiments, concepts too large to test. After all, how do you prove the existence of realities that exist outside your own universe? We can't even observe the full extent of this one. And yet, scientists continue to look for indirect evidence, patterns, mathematical consistencies, experimental anomalies that hint at something larger. In Italy, researchers from the University of Trento conducted experiments that suggested our universe may not be alone, that it could be one outcome among many. Not proof, but suggestion. Enough to keep the question open, and sometimes the question isn't raised by laboratories, but by lived experience. In 2017, a woman shared a story online that unsettled thousands of people who read it. Not because it was dramatic, but because it was quiet and specific. One afternoon, she received a text message that simply said, "Who's this?" The message came from her husband's number. At that exact moment, her husband was asleep in their home. His phone was on the bedside table, unused. Assuming it was a glitch, she replied and asked why he was messaging her. The response was immediate. The sender said her number was saved in his phone, but he didn't recognize her name. Confused, she asked why her number was saved at all. The reply came back with 2 words and a heart emoji. Wi-Fi. That name wasn't random. Wi-Fi was the private nickname only her husband used for her. No one else had ever used it. Later that day, she told her husband what happened. He checked his phone. There were no sent messages, no drafts, no activity at all. To test it, her husband sent her a new message. What appeared on her screen made no sense. The new message showed up beneath the earlier conversation, as if both messages had come from the same source, same thread, same number. One real, one unexplained. There are logical explanations for events like this. Network errors, system glitches, rare but mundane failures of technology. But there is also another possibility, one that mirrors the déjà vu question. If parallel versions of us exist, And if information can briefly bleed across timelines, then connection wouldn't look like portals or dramatic crossings. It would look exactly like this. Familiarity without cause, recognition without history, contact without presence. Just for a moment, two versions of the same person occupying overlapping informational space, and then the paths separate again, leaving behind nothing but a question you can't quite dismiss. Whether these stories point to parallel universes or simply to the limits of our current understanding, one thing remains clear. Reality may be far less singular than it appears, and sometimes what feels impossible isn't evidence of fantasy. It's evidence that we haven't finished mapping the rules yet. So what do you think? Could the idea of a parallel universe sending a text really explain this? Or is there a more grounded explanation? Personally, I'm skeptical. But that doesn't mean the story isn't intriguing. It's worth exploring, because beyond speculation, there are experiments and observations that hint the multiverse might actually exist. To understand that, we need to take a step back and revisit the Big Bang. Most explanations you've seen online only give half the picture. And that's why the multiverse connection can seem confusing. It's hidden within the story of our own universe. Here's the full picture. Right at the start, before anything else existed, all the energy in the universe was concentrated at a single point. A point so unstable that a single disturbance triggered an enormous expansion. That moment is what we call the Big Bang. Whether you think of it as an explosion or a rapid expansion of space, the idea is the same. Space itself stretched, and with it, all the energy and matter that would eventually form our universe. But the universe didn't appear fully formed in an instant. Right after the Big Bang, only space was expanding. The universe we know today, galaxies, stars, planets, took time to take shape. As the energy from that tiny point spread out across the inflating space, it might have looked calm from the outside, like milk sitting quietly in a pot. But appearances can be deceiving. Inside that expanding space, energy behaved like heated milk. The bottom of the pot received immense heat, causing particles to rise, cool, and sink again, creating convection currents. Some particles traveled straight to the surface, while others formed bubbles that rose independently. This simple analogy helps explain a key concept. Even in what seems stable, fluctuations occur. And those fluctuations, the uneven energy distributions during cosmic inflation, may have created conditions that allowed multiple pocket universes to form. In other words, the story of the multiverse is embedded in the very mechanics of our universe's birth. Now let's go a bit deeper. In the boiling milk analogy, the particles that rise as bubbles carry less energy than those moving straight to the surface. Why? Because bubbles contain pockets of empty space, which are less energetic than the surrounding hot milk. That's what makes boiling milk appear calm on the outside, while it's actually unstable underneath. Our universe works in a similar way. The energy released during the Big Bang didn't simply expand uniformly. It created tiny quantum fluctuations, vibrations in space-time. At these fluctuations, miniature bubbles formed. Each of these bubbles could become a stable universe, existing alongside the one we call our own. But is there evidence for this? Yes. This year, physicists from Trento University in Italy, led by Zannaccini, experimentally supported what's known as the bubble universe theory, originally proposed decades ago. Back in 1977, theoretical physicist Sidney Coleman suggested a mechanism for how our universe stabilized after the Big Bang. He proposed that our universe initially existed in what's called a false vacuum. a state that seemed stable but wasn't truly so. Think of a chemical reaction. For a reaction to happen, the molecules first need to absorb enough energy to cross a barrier, called activation energy. Once that barrier is crossed, the reaction proceeds naturally to a stable state. Coleman argued that the universe followed a similar path. Initially, matter and energy were trapped in a false vacuum. As the universe evolved, energy accumulated until it finally overcame a massive barrier, transitioning into a true vacuum. That true vacuum is what allowed galaxies, stars, planets, and complex structures to form, the stable universe we see today. But where do bubble universes fit into this? Returning to the milk analogy helps. Particles in milk can either rise slowly through convection or form bubbles and jump quickly to the surface. Similarly, early particles in the universe had two paths to stability. The first was the slow, ordinary process, gradually overcoming the energy barrier. The second was a shortcut, where particles could quantum tunnel through the barrier. Quantum tunneling allows ultra-microscopic particles, atoms, electrons, quarks, photons, to bypass energy obstacles entirely. Just like bubbles rising rapidly through milk, these particles reached stable regions faster than the main universe could. Each of these pockets became a bubble universe. In other words, from the very beginning, the universe could have formed as a collection of multiple coexisting bubble universes. Our universe is one of them, and it still exists as part of this vast multiverse. So how did the Trento University team demonstrate this in the lab? They used sodium gas to mimic the inflating space after the Big Bang. To replicate false vacuum conditions, they supercooled the gas into a highly uniform and stable state called a Bose-Einstein condensate, or Bose. One remarkable feature of a BEC is that its atoms align their spins when exposed to a magnetic field, allowing scientists to simulate behaviors similar to those thought to occur in the early universe, including the formation of bubble-like regions representing parallel universes. That's why the scientists placed the supercooled sodium gas inside a strong magnetic field. Then, to mimic the Big Bang, they introduced energy into this lab universe. And just like that, tiny bubble universes began to emerge. But the bubbles didn't form spontaneously. First, energy fluctuations at the quantum level were needed to trigger them. To create these fluctuations, the team irradiated the magnetic field BEC with a precise frequency of radiation. As soon as the radiation reached a critical value, DF, something remarkable happened. Some of the atoms at the center of the BEC suddenly transitioned into a more stable state, forming tiny bubble-like structures. Essentially, these atoms moved from a false vacuum to a true vacuum, just like the quantum tunneling process we discussed earlier. You might wonder, how can atoms move to a lower energy state when energy is being added? Intuitively, adding energy should make them more excited, not more stable. The answer lies in the magnetic field. Think of a small magnet inside a larger magnet. The smaller magnet naturally aligns with the larger one, reaching stability. If you apply energy to force it to rotate, it resists at first. But once it flips, it settles into a new, stable configuration. That's exactly what happened in the BEC. The atoms flipped magnetically, became more stable, and grouped into bubble-like universes. This experiment shows that inflating space can transition from a false vacuum to a true vacuum in the form of individual bubbles, each of which could represent a universe. But does this prove the multiverse exists? Not entirely. There are limits. Unlike our universe, where we can study the cosmic microwave background radiation to gather evidence from the Big Bang, we don't yet have direct proof of other bubble universes. It's possible that the evidence is there, hidden in the CMBR, but we simply lack the tools to detect it. In fact, recent data from the James Webb Space Telescope has already challenged our assumptions about the universe's age. According to this data, the universe may be far older than previously thought, almost twice as old in some estimates. What does this mean for cosmology? Why are scientists recalculating the universe's age? And could these findings hint at a multiverse we've yet to observe? I've covered all these questions in detail in another video, so check that out if you're curious. That's all for today. If this video sparked your curiosity or gave you a fresh perspective on the multiverse, hit the like button, share it, and subscribe to the Get Set Fly Science channel. Stay curious, keep learning, and keep exploring the universe. Because the more we discover, the more fascinating reality becomes.